So once again, good evening to all. I will start with my formal welcome speech. The keynote speaker of the day, Dr. Ranjan Saman, Technical Fellow at DuPont Biomaterials USA. Asim Panji, Reliance Industries Limited, he is a FDY head, I suppose. Shri Nagaran Gauriji, DuPont India. My colleague, Mr. Suresh Patel. Other invited guests, member of SGCCI, participants from trade and industry and past president. A very good evening to all of you. I welcome you all to this once in a lifetime opportunity to listen to the senior most technical fellow of the world leading chemical company DuPont, which is ranked at 35th on Fortune 500 large global entities. Our keynote speaker, Dr. Ranjan Samant, is a technical fellow at DuPont Biomaterials USA and currently responsible for developing and implementing Sarona growth strategy. Dr. Ranjan received BTech from Indian Institute of Technology, BHU Varanasi, Masters from Manitoba, Canada, and PhD from University of Minnesota, USA. Dr. Ranjan joined DuPont in the USA in 1985 at its first nylon plant in Seaford, Delaware, where he led development of nylon staple and recyclable nylon carpet. He moved to DuPont Central Research and Development at Experimental Station in 1997 to work on high-speed spinning of nylon industrial fibers. Over the year, Dr. Ranjan developed a stretch break process for Kevlar, explored lightweight ballistic protection, flame retardant, polyceride applications. Since moving to DuPont Biomaterial in 2015, Dr. Ranjan has been involved in range of strategic programs for Sarona polymer, such a new fiber application, recycling, flame retardancy, value chain transparency. He is a co-inventor of 22 patents and authored over 40 internal and external reports. Friends, DuPont is nearly 200-year-old company and was the first company in the world to introduce polyester fiber for the commercial production. The polyester was first invented in early 30s by DuPont engineer. It was then first time converted into fabric by British scientists in 1941. And thereafter, DuPont has taken over the patent right on the product and since then has been promoting polyester fiber across the world. Reliance Industries Limited, which is one of the largest polyester manufacturers in the world, has driven this innovation in India. And today, India is the world's second largest producer of polyester. It is estimated that global market of polyester fiber is around 90 billion US dollars. That is Indian rupee terms, it is nearly 6,30,000 crore. This very same fiber is then converted into variety of end-use products like fashion textile, home textile, engineering and automobile textile, etc. Since its invention, the fiber properties has been enhanced for the use in various applications in blend and raw form. So the growth of polyester in India and growth of Surat as well as the world, Surat is the world's fastest growing city in the world. And Surat is also the MMF capital of India. Surat contributes 65% of the total MMF production of the India. So Reliance Industry has set up its MEG and PTA plant in Hazira because Surat was the only city during those times to have twisting facility. The FDY produced by the Reliance Industries needed twisting facility and therefore the initially Reliance promoted the job work for the polyester gray fabric in Surat and introduced the printing method for the printing of gray fabric made from polyester yarn through already ready-made availability processing capacity of the Surat. Before that, those facilities were used for nylon fabric, in which Surat was already pioneer across the India. Since then, there has never been looking back for the polyester industry of India. Today, Surat possesses around 33% of the weaving capacity of whole of India. and concentration of 80% of the modern weaving facility in India. Near about 7,15,000 power loom are now operating in Surat, producing nearly 4 crore meter of fabric per day and using around 10.5 lakh metric ton of polyester per annum in Surat itself, out of 19 lakh metric ton of consumption in India. Surat contributes nearly 50% of the polyester yarn consumption of all India. With this correlation of the growth of polyester in India and that of Surat, and a coincidence of our 81st year of the establishment of our chamber also. And the world is celebrating the same for the polyester yarn. We have decided to celebrate our all upcoming exhibition on textile with the tagline of 80th year of polyester era. To celebrate this historic event, thankfully, today we have with us Dr. Ranjan, who belongs to the same company who initiated the commercialization of the fiber for the very first time in the history of the world. I am sure that his inputs on polyester will enlighten as well as in all our journey further and augmenting the growth of not just the polyester business, but furthering the cause of the development of Surat. So once again, I welcome you all and I request Mr. Ranjan to start his presentation. Sir. Welcome.
Thank you very much for a very nice introduction. Namaskar to everyone and good evening to everyone. Looks like I'm a lot of activity at Surat over the years and decades, and hopefully as a result of this presentation, we will continue our collaboration and work together. If you can give me rights to share my screen.
That already given.
Okay, okay, good. Do you see my first chart here?
Yeah.
Yeah. So again, thanks very much for inviting. What I would like to do today is talk about polymer innovation at DuPont from the point of view of polyester, and then that nicely weaves into Sarona, which is a type of polyester, as many of you might know. So the order here is I will go through some brief history of invention of polyester at DuPont. As Ashish Bhai just mentioned, there is some twist to the story. I can provide a little bit more background around the invention, and then spend most of my time looking forward to the polymer that we are currently making and selling that goes into various apparel applications. It has unique properties, provides durable stretch and performance and longevity. So we would like to cover that. Compare properties against Spandex, and you will find that Sarona provides a very compelling properties and is a good candidate where Spandex is currently being used. In addition to that, we'll talk about sustainability aspect. We'll talk about our certification program that we are very much engaged in, and then cover some product introductions and summarize. So as was mentioned, DuPont started in 1802. It was started by, give me a second to move this box. Started by a French-American chemist named Eleuthère Irene DuPont de Nemours, and he started the company at Wilmington, Delaware, and the company took its name. So that's why EI DuPont comes about. At one point, DuPont was the largest supplier of gunpowder to US military during the Civil War, and with supplying about 1/3 to 1/2 of the gunpowder. Shown on the bottom right is the original gunpowder wagon. Obviously, that site is now a very good museum, Hagley Museum and Library that documents the history of DuPont businesses and technology. It's a US National Historic Landmark. If you get a chance to visit us here, we would love to take you and show you the museum. I'm having difficulty going to the next slide. So in 1903, DuPont established R&D center, and shown here on the left is 1928 aerial view. Obviously, it was recognized by the leadership then that research is very important in developing new polymer and new products. They were looking at developing new polymers at that point. On the right-hand side is the more recent image. I don't have the current one. But you get a picture that it's a very much campus-like environment, a lot of different science centers and a lot of different scientists who work on various projects. In 1928, DuPont approached Wallace Carothers, who was at Harvard at that time. And it took a lot of convincing to bring him on board. He had severe depression, chronic depression, and he realized that, and he did not want to leave university and come to a company. But we were able to convince him. He came, and as you can see, he had a very short life, about 41 years. During his depression, although he had invented neoprene, which is shown on the right here in 1930, and obviously polyester and nylon, he thought that he had not done much in his life and ended up committing suicide. So that's a very tragic end to a genius, and a lot of these geniuses are very crazy people. Ironically, they had a daughter the same year he died. But remarkable productivity, remarkable genius, and that kind of ushered the era of modern polymer science. Over the years, DuPont has come up with a lot of polymers, many of which you already know: the nylon 6,6, PET, and then Dacron fiber, which comes from PET, polypropylene. Numex is the fire retardant polymer. Lycra, of course, and Kevlar is the ballistic resistant. And latest one is Sarona, and it is shown here at after 2000, even though the polymer itself was invented quite early, because the Sarona that we make and sell is partially bio-based. One of the monomers or one of the major ingredients comes from corn juice. So that's why we show it at that time frame. About polyester, it was prepared by Edgar Spanagle, who was a chemist working with Wallace Carothers in 1934. About the same time, DuPont was also looking at nylon, and they prioritized nylon over polyester. And as Ashish Bhai said correctly, a group of scientists who were familiar with the work going on at DuPont also discovered this polymer. They patented it as Terylene and sold a 20-year license to ICI. So there's a lot of twists and turns here. DuPont then finally resumed their work on polyester. In early 45, they purchased the rights to Terylene and from ICI, and they went ahead and developed the fiber V, which is Dacron, and started production at Kingston in 1953. So it has a little bit zigzag history. With respect to plant itself, started in 53 construction began in 51 to 53. You can see the image on the right top is the 1952, the construction going on. The bottom one is more recent picture. I don't have the year to go with that. In 55, the Dacron Research Lab was started, and till about 93, it was the golden era. The Dacron Industrial Yarn, the startup of Cape Fear and Cooper River plants, the first POI line, and the second POI line, and the third PO line in 1993. About that time, 1998, Kingston started looking at Sarona polymer, which is the polymer that we make currently there. And in 2004, DuPont exited the business, nylon and polyester, and sold the business to Koch Industries. 2007 is an important year. That's where Sarona became bio-based polymer, probably the single most high volume commercially available bio-based polymer that's there in the world. And then we have been increasing capacity since then. A side story, I was hired in 1985 at Kingston plant, then was asked to go to Seaford, Delaware, where nylon was first produced. So I never got to start my career there, but now I'm back to there, and we often visit and talk to folks at Kingston. So interesting turns of event for me personally. So that brings me to the story that we want to cover about Sarona. You will find that it is a unique polymer, and part of uniqueness goes to the molecule itself. It provides certain attributes that is not easily found in other polymers. As shown here, the polymer can be used is currently used by our customers into 4 different types of filament: homofilament, FDY or DTY, which is texturized yarn. The counterpart of that is the homo staple, shown here on number 3. That can be blended with various natural fiber and rayon. And the bicomponent stretch filament, which is very interesting, and some of you may already be familiar with that. It's a combination of PET polyester and Sarona, which gives it a unique property, and we will discuss quite a bit in subsequent slides. And the counterpart of that, in number 4, is the bicomponent stretch staple fiber that can again be combined with natural fibers like cotton, wool, rayon, and the like. So our customers take polymer, we sell polymer to our customers, and they convert into fiber in different forms, and then the fabric is made by subsequent partners in the value chain. We have had a very good success in India in spurts, and I'm hoping the discussion we are having today will lead to further solidification of the relationship we have had with India. Some of you may know in 2015, it goes back to, our presence in India goes back to early 2015. We partnered with Reliance and Bicol to make the first green sari here. Shown here is Mr. Anil Agrawal from Bicol Fashion, and on the right is Balwinder Singh, the then president of South Asia in DuPont, flanked with Bollywood celebrity there. And then more recently in 2017, we invited the leadership of Sanjay Swaragi and Nilesh Bhai to our plant in Loudon, Tennessee, where we make bio-based propane diol PDO, which goes into making Sarona. Shown here on the left is our marketing director, giving him an award, and on the right, the second person from the right is our business director, currently CEO of the business. So we have had a couple of very good collaborations with our partners in India, and we are very thankful for that. Now I want to talk about stretch fabric, which is where I want to spend most of the time and amplify the properties that Sarona can bring to the garment. So the first question is why stretch? The primary reason is that the demand for stretch continues. You may have seen in your businesses, as we do, stretch is everywhere, and partly it's because the comfort it provides. Personally, for me and our family, we gravitate towards garments that have a little bit of give, so it moves with your body, it conforms to your body. It just feels comfortable and good, whether you are in outdoor activity or inside formal wear. It's everywhere, especially in women's wear. Also, stretch is found in all the different applications. So that's the reason to look at stretch as a key property for the polymer that we sell. So what is wrong with the stretch that's currently available? And one of the things that we noticed, and I'm sure you have seen that as well, that the stretch garments that are currently being made, a lot of them develop baggy. They become baggy in the areas of repetitive motions, like elbow and knees and pockets and hips, especially the fabrics made with spandex tend to deteriorate with time as they are repeatedly washed and go through the dryer cycle. They're impacted by bleach and other chemicals, and once they go bad, people tend to discard them. In US alone, about 13 million tons of textile is thrown every year. So that's a lot of textile waste. A lot of it, or most of it, just goes into landfill. So if we are able to extend the life of a garment by 9 months, that has a very significant effect on reducing carbon waste and the water footprint by as much as 20 to 30% each. So there's a lot of motivation to keep the fabric new for longer time. So we talked about why stretch is important. We also talked about what is wrong with current products that use spandex. So the question is, how does Sarona Stretch solve these issues? And I think for that, we need to just little bit look at the molecular structure. Shown below here is the unique polymer structure of Sarona. As you can see, unlike polyester is a straight chain. Sarona has a more of a helical coil kink in it. So when the fiber is stretched, these chains elongate, and the structure is such that when you remove that force, the chains go back to this preferred state of zigzag, and chain is able to move even in the crystalline region. Therefore, it has a very good recovery. So the lot of benefit that we see is that it has a natural stretch. It has a unique hand feel because of the molecule, which is more like a spring rather than a straight chain. So you'll feel the fiber to be very soft. It stretches by itself, but if you combine within a Bicol, you can get significantly more stretch. Because of these properties, in US, Federal Trade Commission has granted a new generic, which is Triexta, and that's what our customer in US use. One of the application for polymer is in carpets. We are not going to talk about carpet, but just to highlight, the carpets made with Sarona have very soft feel under the foot, which people really like. And since it is a polyester, it's naturally stain resistant, as opposed to, say, nylon. So these are the unique properties that we exploit in our stretch garments. So again, looking at now from the stretch point of view, the 4 categories we talked about, the 100% staple, 100% filament, the stretch, which is it could be 50-50 or it could be 30-70 or 40-60, different ratios of Sarona and polyester, both in the filament and in the staple form. And they provide different kind of properties, and they all lead to different types of certification, which we will talk towards the end of our discussion here. So let's capture the unique attributes of the yarn. It is easy to spin, easy to produce. And here is what I mean. For the fiber spinning part, from polymer to fiber, people often use, we can use polyester spinning acid or nylon spinning acid. And that's what is being done, say, for example, in China or Europe. We are exploring South America, and we would love to see something come up in India as well. The fabric formation, there are some certain advantages that we'll talk about, especially when we compare to spandex and downstream processing. And one key point to highlight here is that we have technical resources in India. Of course, Gauri, you know, Akshay Kumar and his team is there to help you in different aspects. We are here to, we normally send people who are experts in spinning to go and start up the plants. And for example, in China, we started in the beginning, people used to go there to spin the fiber. Now they are self-sufficient and they know a lot about the spinning of the polymer. It's ideal for comfort stretch. So that will mean that it's a casual wear, active wear, formal and swimwear. It doesn't have the same power level as spandex. So for example, if you're looking for power stretch, where a lot of stretch and recovery is required, very high intensity aerobics or very high intensity activity, then there we tend to combine with spandex. But otherwise, for casual stretch, casual wear, active wear, formal and swimwear, Sarona does really well. We'll talk about a little bit later that it is not impacted by washing or chlorine or repeated use, so it provides long-lasting stretch. It can be dyed, so unlike spandex, it's a polyester, so it can be dyed and has good fastness properties. For fiber filling application in as a staple, it provides good warmth retention. And finally, it's sustainable, as we have been, I have been alluding to. One of the monomer comes from the plant-based source, and therefore it's a partially bio-based. It can also be recycled. We'll talk about recycle a little bit later. And also the Bicol PET and Sarona Bicol, the PET could be recycled PET as well. So there are beginning of life advantage and the use advantage and also sustainability advantage towards the end of the garment's life. So because of these, our customers who are spinning fiber, it goes into different application, and some of them are just shown here as images. Women's wear, denim, swimwear with georgette or chiffon, intimate apparel, and you can see the list is pretty long. Suiting, insulation, yoga wear, knitwear. It's used many places. So I want to talk about and compare Sarona against Spandex. Because we're talking about stretch, we should discuss that. And so I would like to start off with mechanism of stretch for Spandex. And it's important to understand that the stretch in Spandex happens at the molecular level. And we don't need to worry about the chemistry, but just to look at pictorially, it has a soft rubbery segment and it's a hard segment. And it provides stretch by opening up the soft rubbery segment. The hard segment is what provides the strength. So soft segment provides stretch and the hard segment provides strength to spandex fiber. And part of the issue is that the hard segment does not melt. So if you take a spandex polymer and start heating it up, it won't have a melting, it will just carbonize. Because of that, the spinning of spandex is done not from melting, but from solution. And a lot of these solvents like DMAC or DMF are reproductive toxins. So you have to be careful. There are a lot of, obviously it's made in huge quantities, but you have to be careful how you use it, and you have to be using right productive equipment and so on. And because it does not melt, it cannot be recycled as well. So a lot of garment have, since it has very low amount of spandex, they can go by, but spandex by itself is not recyclable. And since the stretch happens because of the molecule, those molecules get attacked by chlorine and bleach and UV during use, and after repeated stretch and recovery, it begins to lose its properties, and we will show you some of the properties in subsequent charts. Shown on the left is the cross-section of the spandex fiber. So when it comes to stretch by Sarona, it is quite interesting and quite different from how spandex works. It comes from the bicomponent nature of the fiber itself. So if you look at the left image here, it's a cross-section of the fiber. Unlike a spandex, which was a round cross-section, here you have two polymers, PET and Sarona. And because they have different molecular structure, one is straight and one is zigzag, the combination of the two leads to stretch and recovery. And you can also affect that by the viscosity of each polymer. So if you keep the viscosity of the PET very low, as you stretch the fiber, the Sarona polymer chain will become straight. And then as you heat it up, it will try to go back to the zigzag configuration and therefore create stretch like or helix like here, shown here. And that's because of the differential shrinkage of the two polymer. And that mechanism of stretch is quite different from the stretch that you see here in the molecular level and in the previous slide with respect to spandex. It acts more like a spring. Another side benefit of this side-by-side structure is that there are cavities that are formed at the interface, and they act as capillaries, so it enhances the drying rate. The garment dries faster than the spandex containing garment would. So those are some key fundamental difference between the two polymers. Of course, in addition to Bicol, the Sarona itself has a stretch to it because of the kink in the molecule. And so it itself can stretch more than PET, for example, and you can further enhance that by various textural mechanisms that I'm sure we are all very familiar with. So with respect to fabric construction, one of the things that we have to learn, and because it's a different polymer, the stretch happens at an optimum temperature. And that temperature, for example, shown here at 90 to 100 degrees C, will depend on the heat history of the fiber as it was produced. What was the heat set temperature during spinning, what was the draw roll temperature, and so on. And because of that, there might be slight difference from different suppliers. But once you know what the optimum temperature is, that's where you want to heat the fiber to create the crimp that we talked about. The other part is the structure has to be more open, so requires more open fabric construction so that the yarn can shrink freely. It also improves the fabric hand feel. And again, we have experts in India who can help you, provide the guidance and work with you in designing the right fabric for our polymer. So I put together this table and I thought it would be good to go through this, comparing spandex versus Bicol. So spandex is typically used for very high stretch, say 50%, up to 50%, whereas Sarona Bicol will go up to 30%. It needs to be covered, as we know, spandex needs to be covered, which adds to the cost and additional step. It is covering because of the hand feel of spandex, the lack of diability of spandex, and those are not issue with Bicol. It's processes like PET, and therefore, since no coverage is required, you eliminate that step, and therefore it's more cost effective from that point of view. The spandex cannot be twisted. As you know, the part runnability is difficult, and you need special tension control devices on the loom to maintain elongation and other properties. And Sarona Bicol lets you get away from all of that. It can be twisted, texture to create drape and fluidity that you need for women's apparel, can be used in warp without additional accessories as you will need in spandex. Spandex loses its property under tension, temperature and humidity control storage is required. And again, warp can be held for several days in the standard storage condition. The damage of fabric with caustic is a big issue in spandex, and caustic treatment can be used for Sarona Bicol, which is key to improving drape and softness. So there are a lot of processing advantages as well as property advantages. We are all aware the spandex doesn't take dye. It will take some, but then it kind of comes out. But on the other hand, Bicol provides brilliant color, excellent color fastness. We talked about the stretch is long lasting here. We will have some data later in the chart. The stretch from spandex degrades over time after washing and repeated use. Therefore, I think you'll find that Bicol can be used in many places where active wear and comfort stretch is required, whereas spandex is ideal for power stretch application. So here is some data. We are looking at cotton core spun spandex. As you can see, in the beginning, it has a higher stretch than Sarona stretch filament, but Sarona stretch filament maintains the stretch for number of washes shown up to 25 here, whereas cotton core spandex begins to degrade and come to the point like 40s, from high 40s to low 40s. The recovery after 1 minute, that has to do with the bagging. We talked about the repeated like elbows and knees. Bicomponent filament has excellent recovery in 80s, whereas cotton core spandex like Lycra has reduced recovery. So those are the remarkable differences we find in our Sarona stretch fiber when we compare that to spandex containing fibers. Here is another data set on denim after 25 wash. You can see it's not maybe not coming through very clearly, but the fabric had lint and fuzzy appearance, whereas Sarona Stretch filament had very good appearance, retention after 25 washes. Chlorine resistance, we are showing here 3 types of fabrics, nylon spandex, Sarona spandex, and Sarona PET Bicol. As you can see, there's very less weight loss with Sarona fiber here. With respect to growth and recovery, after 1 minute during this test, the nylon spandex item was completely disintegrated, so we couldn't test that. So there's a lot of damage there. And you can see the stretch recovery for Sarona spandex, and especially for the last bar chart here, which is the Sarona Stretch filament, is very good. So it has good performance against chlorine. It has good performance during repeated stretch and recovery. It has a higher recovery than initial recovery than spandex would. So those are the property of the fiber and fabric and where it comes from. I want to switch gear and talk about sustainability advantage. As we talked earlier, the Sarona sustainability starts from the beginning as one of the monomers, the PDO, comes from annually renewable feedstock. So we take corn, we take that and derive sugar or glucose from the crops. Then we add enzyme. There is a major discovery that went into designing the enzyme, which takes it in single step from sugar to bio-PDO. And then we add TPA to the bio-PDO, and then that results into Sarona. This is very much unlike petroleum-based polymer that we are very familiar with. Here we are comparing the renewable part, the sustainability of Sarona against nylon 6. This chart was relevant for carpet where nylon 6 is, we're comparing against nylon, but you will see the sense even in apparel also. We talked about 37% coming from renewable plant resources. During manufacturing, it uses 30% less energy than the nylon would, nylon 6 would, and it has 50% less greenhouse gas emission. So those are some additional good sustainability advantages that we see. We have gotten a lot of certification. Shown here are the 4. At the top left is USDA, US Department of Agriculture certified bio-based product. It has a certification from Biomass Plastic Association in Japan. Blue Sign system. We recently got that endorsement, and Sarona fiber has gone stringent testing under standard 100 OCO-TEX to certify that it is good, safe for use with infants and toddlers. So we continue pushing our sustainability advantage in the businesses that we are in. And finally, the recycling part. So here we are showing fiber and fabric recycling. The chart on the left is fiber recycling, on the right is fabric recycling. In both cases, the fiber or fabric was taken and chopped up and repalletized. So we take used fabric or used fiber or industrial waste fiber, and we cut it, make pellets, and then we're feeding pellets back into either PET spinning. So this will be 100% PET. Then we are adding 5, 10, 20% of this fiber waste, or we are doing the same thing in PTT spinning. And we are showing here that we can take fiber and fabric, and it can be put into PET stream for recycling, and we can make a product out of that. We are showing a 3DPF PET yarn or 3DPF PTT yarn being made. The challenge here is to find an application where apparel can be recycled into, and customer will pay money for that. But this data does show that there is a good story about recyclability at the end of its life. I'm not saying that 3DPF is the final product. It's just a concept demonstration that you can take our fiber and fabric and recycle into a melt stream, just like you would do with PET fiber or fabric. So the other part that we want to talk about is the certification program that we have, and that is needed because we want customers to feel good about the product that they use, and they want to make sure that it meets all the requirements of traceability and transparency and the properties. So I'll go through an important statistics here. We have 350 certified fabric mills worldwide, and as we certify, as the garments are being made, we provide hand tags. This is a photograph of the hand tag. As you can see, 43 million, roughly 44 million hand tags have been provided. This is a recent program that we have launched. So the branding works in a following way. The Sarona polymer is the master brand. Polymer is what we are selling, and a trademark license agreement is needed to be able to use Sarona polymer as a tag on your product. Then under the fabric itself, there are two categories. One is the Sarona ingredient brand. So the tag might say contains Sarona, and if it stops there, then we provide the testing for the content, but we don't provide any performance certification. So this is like Intel Inside in the computer. This will be like Sarona contains Sarona. Now, with respect to fabric, there are 5 different categories, and these then lead to fabric certification, and they have a different hand tag that goes with each of these. And in next few charts, I will give you very high level attributes of each of those. So other than insulation, these 4 are the fabric level, and then this last one is the insulation. So let's look at that. Profile fabric, the typical application would be outerwear. Here we are talking about shape memories, which means it's 100% PET. The fabric must contains 50% of homo fiber in fabric, or contains 100% homo fiber in the warp direction. It provides shape memory, wrinkle resistance, and a smooth hand feel drape. We have technical data that goes behind all this. For sake of simplicity and time, I'm not presenting those here, but those data set is available for people to look at. And the second one is then the Agile Fabric. Here we are bringing the stretch that we have been talking about without use of spandex. So the typical application might be in yoga or athletic wear, outdoor apparel, denim, ready to wear, high fashion. and the benefit you get is the stretch and recovery without spandex. All the benefit that we talked about during production of the fabric, the performance, long-lasting, durability, durability, and all that we have talked about. The requirement here is that it contains minimum of 20% of polymer in terms of the fiber, and does not contain, but it does not contain spandex. So that will be Sarona Agile. Then Sarona Revive, as you can see in the image here, is more of a power stretch application. So it will go, for example, in athletic wear, it may go into swimwear and intimate apparel. Here we are providing 20% of Sarona polymer with spandex, but this spandex doesn't need to be as much, which contains less spandex, and therefore it has longer lasting durability. Sarona Luxe is the staple version. So here we are combining 10% homo stretch staple with at least 50% of natural fiber. So they could be cotton, linen, wool, cellulose, and it is ready to use high fashion, such as intimate apparel and suiting. It provides good softness and dimensional stability. All the benefit that you will see from a typical staple fabric by combining different types of polymers. And then finally, the insulation part. It is for outerwear, home textile. It is meant for warmth as measured in Clo value, stretchability, lightweight, and the requirement is it contains minimum of 24% of Sarona polymer. With that, I think the last part I have is the product introductions. This image I grabbed from a YouTube video that Gauri shared with me. It's very well made. I'm sure you have seen it. I felt very emotionally connected to India after watching this video. Very well done. My wife liked it too. So this is thanks to Lakshmipati, and again, thanks to Reliance and Lakshmipati in bringing these innovations to India, and we would like to continue building on those. Recently, a few months back, Wellspan launched a sustainable bedding and bath collection. I assume it's going well. So this is it provides moisture management, drape, smoothness, and soft and hand feel, which is all the attributes that people want in home textile application. Thanks to Jayashree Textile for launching this blend. This is with blend, so this must be staple, Sarona staple that is blended with linen to provide all the attributes that we just talked about. In just before pandemic, we on the photograph here on the right side, that's me. Center one is Howding. He's our marketing manager in Europe. Left is Akshay, who's in India, technical manager for end-use applications. DuPont was awarded Trend Best Product at ISPO for faux fur. Very well received in the market. And finally, China team has been working with Satari, which is one of the leading producer of viscose in the world. They have Eco Cozy, and now we are working with them to blend Sarona with viscose and the attributes that those two polymers bring together. On the right-hand side shows the Olympics team, Chinese Olympic team wearing uniform that was designed with Anta, who is one of our preferred customers in China. So there's a lot of activity going on in China. We have a lot of customers who spin fiber from polymer, and then a lot of value chain resides there, as you might know. And this last, I have a summary chart after this. I put together this with our marketing department to, yes. Hello? Are you able to hear and see my charts? I'm assuming yes. And the last chart here is summary. What we talked about is Sarona is the latest innovation from DuPont, which has already introduced Tecron, Nylon, and the brands that you're very well familiar with. It can be extruded from equipment that's used for polyester and nylon. Fiber and fabric processing is similar to polyester, although you have to have a more open fabric construction, so the fiber can shrink freely. It offers an excellent alternative to spandex, requiring comfort, stretch, and beyond. Polymer in Sarona Stretch fiber are relatively inert to bleach, temperature, oil, UV, stretches, long-lasting. Fibers dry well, as we talked about. It has good sustainability profile. It starts off with biosourced monomer, and at the end it is recyclable. The fiber and fabrics both are recyclable into PET stream. We have a certification program, and many of the brands are using Sarona, as we just talked about. So that was the last chart. Again, I thank our partners, our customers, and thank SGCCI for inviting me to speak about our polymer and give a very brief history of polyester. I hope you enjoyed it. If you have any question, we can address that.
Yeah, thank you very much, sir. It was indeed in-depth, detailed explanation about your product. So we have on our panel our past president, Mr. Bharatbhai Gandhi.
Hello.
I request, Mr. Bharatbhai Gandhi is the chairman of FIASFI, and he is a leading industrialist, and he is a long last experience in textile industry also. So I request him to say a few words. Bharatbhai, unmute yourself, sir. Bharatbhai.
Yeah, thank you, President, and thank you, the main Mr. Ranjan Bhai. The speech you have given is very informative, and particularly Spandex, and you made mention about cellulose also and other yarn also. So now the future of the industry, particularly textile industry and man-made fiber, is in India. And in India, I think our share, South Gujarat share is 60%, but I foresee within 3 years it will reach 75% in India. And even from China also, and from Vietnam also, we can take some bites, about 5 to 10% will move, industry will here. So from the spinning to the second stage and fiber, and from that to the weaving, whole industry I see flourishment as it is, unless and until government don't disturb the policy. Just now, according to your spinner, it may be 12% may be viable, but from 5 to 12 on the fabrics, which they are, this is not a subject to discuss here, but I'm just drawing one kind attention that government is 5 to, so they may disturb the industry, because after Corona and GST, industry is getting slowly and slowly on the track. If any don't think adverse comes from the government or anything else, I see the flourishment of industry is very well. Future of the man-made fiber is very well, particularly polyester and nylon and viscose always. So, and you had given very with the fabrics example. I compliment you. Thank you very much.
Thank you very much. I would really like for us to collaborate, because as a Indian from India, who left India, so would like to go back and provide. It will be really nice to see the work I have done for what 37 years overall.
Yeah.
Connection to India.
Yeah, Dr. Ranjan, it's good suggestion with our collaboration with Chamber, and I'm a council member in Sasmera, Mumbai also. So we can do something, and because we are having also good scientists there. Even Mantra is also here, but Sasmera is big in it. And I'm a member of Textile Committee, Government of India, Ministry of Textile also. So I think these collaborations and the benchmarking will definitely help the industry.
Thank you.
Thank you, Bharat Bhai. So, sir, I have one question. Basically, what's the price difference between the Spandex and Sarona, sir? Just percentage-wise.
So Gauri may have more. If he's online, he probably has a more of a feel for price of the both fibers in India because of the import duty and so forth. We can provide the pricing structure. What will be the price for Sarona? You're talking about polymer or fiber? It depends on
Fiber.
Fiber, then we'll have to think about where the fiber is being spun. As of now, to by best of my knowledge, we don't have a fiber spinner in India. So you have, we end up importing from China, which then poses import duty. So that has been part of the struggle in growing our presence and our business and collaboration in India, because we don't have the key part of the value chain. If we could spin there, then we'll have a different price structure.
So, sir, the government of India has announced 7 mega textile park recently. So this facility can be developed in the same mega park, and one of the park has to be established in Surat. So, so that can be established in the same park. Another question is, sir, the antiviral and antibacterial, or basically antimicrobial properties are nowadays inserted in polymer itself.
Yes.
So what is the life, I mean, in terms of number of washes, and can it be enhanced? Because nowadays everybody is very much conscious about this antimicrobial, especially in Western countries. They are using this in home textile.
Yeah, so we have to separate antiviral and antimicrobial. Virus, as you know, won't work with typical silver containing antimicrobial additives. The antimicrobial additives that we have looked, our customers use it. In China, they are looking into putting antimicrobial additives during the spinning process. We have briefly looked at it. We don't have a product right now, but that's one of the areas that we will be looking at in future as to what functionality we can bring into the polymer itself. The challenge is that a lot of these are silver containing, like Dow had silver door. You may be familiar with that. And silver is not very, certain parts of Europe, silver is not very favored. So you'll have to look at what is the right additive, and then how many washes it can sustain, and what it does to the fiber spinning and so on. So I personally have looked at an additive from American, and it had good profile in the beginning, and then the question was how many washes can it sustain. But that's a good, if there is a lot of interest in the market, that's something that we can look at.
Thank you, sir. So some of the question has been already answered by Mr. Gauri. So once again, I'm thankful to Dr. Ranjan. Your detailed explanation of the application of the Sarona polymer and fiber. And we are excited to know that it can be twisted, textured, because Surat being a hub of this twisting and textured yarn, and it has to be open construction fabric so that it is allowed for the shrinkage. The stretch is more long lasting than the spandex, and also the warping can be stored for the longer period. This is the practice in our Surat, and ideally suited for the active wear. Definitely, Surat weaving industry will get the boost with the introduction of this new polymer and fiber. And we are happy to know that it's a sustainable yarn, consuming low energy, it's recyclable, and it's wrinkle free. So we need to have a more information about this. We can introduce this in Surat textile industry. So we can collaborate with you, and we can have an engagement with you on a regular basis. So very much thank you very much, sir. I'm thankful to the Reliance team also for connecting with you.
Yes.
So once again, thankful to all of you, sir. Thank you.
So thank you very much. I especially like to thank Panji from Reliance, who connected me to the activity. Also, just note that Neil Mani, you may know, he is our local expert who's in Surat area. We can provide his phone number and contact number. He a good resource. He's very much familiar with industry there and what the requirements are. Of course, Gauri is there, and so we have a whole team, and we would love to work with you in future.
Thank you, sir. One more thing I would like to seek your cooperation and help regarding. We are establishing a mega common facility center in which all the textile, right from fiber till garment, we are going to create a facility for testing and certification, product development, market development, producing, a pilot production. So it will be a 360-degree the thing, and everything covered under one roof. So we will need your expertise and cooperation to setting up for this mega CFC center.
We'll be delighted to work with you. What's the frame for that?
Pardon?
When is it coming?
We are going to, we are preparing a DPR and present it to Government of India and Gujarat government. And after they sanction this, we are going to implement. It may take around 6 months, but for preparing the DPR, what all component has to be covered in CFC, we will need your help, sir.
Okay. Thank you very much.
Thank you, sir. Thank you.
We wish you a happy new year and very safe and healthy 2022 under these circumstances. I hope everybody is doing well here. Thank you.
And doctor,
thank you.
Doctor, wishing you the same. Wishing you the same.
Thank you.
Thank you, sir.
Thank you, President.
Thank you.
Thank you. Thank you, President. Bye-bye.
Bye.